Okay, 6-7, point slope form, in theory, next quiz on Tuesday. I think to start out here, I'm going to introduce the formula we're going to need here. So this is our formula that's going to drive everything that we're going to do today. And get used to this formula. We will use it a lot the rest of this chapter, along with the other formulas that we've been using. And what we got here is m, of course, is still the slope. We're going to need to know the slope here. And this y1, x1 here are actual coordinates. We need one actual coordinate to solve these here. And the first ones that we look at here, we see, put that back so you can write here. But keep this formula in front of you throughout the lesson here today and when you're doing the homework. But to solve this here, when it's done, and plug all this stuff in here, we will get an answer that's in perfectly wonderful slope-intercept form here. And what we need to use point slope, again, it's another way of being able to graph lines here, but with some different information. It's not a given we always know what the y-intercept's going to be, and it's also not a given that it's going to pass through a super clean whole number like it's been doing for us here. So in that case here, even looking at a graph or graphing, your point may not necessarily lie on the y-axis there. There could be points, but it may pass through the y-axis at a point you can't visually see. So we need a different method to establish equations when we know some information here. But the things we need to use point slope form is we need to know the slope. And on the front page here, that is provided to us. And then we get our one coordinate that we're going to be able to use. Yep, grab what you need and yep, just head out there. So notice here closely here, and we talked about this before, that they're going to shift our forms around here. But on the front page, again, we're going to work through this here. And we're all done. Things are going to come out generally in slope-intercept form. But look at the directions. I want you to write the equation in standard form, which means we're going to have to fiddle around with it to get it in that form. Flip it over to the back side, and now this time they're going to want you to write your answer in slope-intercept form. And again, this is going to be a theme of this chapter here. They're going to keep switching, and ditto on your quiz and test. I told you, you're going to have to make sure that you read the directions and that you answer it in the form that is asked of you. So our last couple lessons we've had opportunities to kind of get used to going between the two forms. If it's in standard, how do we get it to slope-intercept? If it's in slope-intercept, how do we get it to standard? So let's look at number 3. And what it says is m equals 6 with 2, 2. So what it's telling me here is, again, we're not graphing these here, not what we're doing. There's no graphing, except for at the very end. You'll have to graph this one out here. Talk about that. But what it wants us to do is basically generate the equation of this line. So what I can do here is, again, I'm going to use my formula. I'm going to write it out one more time, and I'm going to plug in what I can. Okay? So m is my slope, and that's going to go right in there. Now, this x1 and y1, these are coordinates. Just like when we dealt with our other equations, we don't have anything for y or x. Our final answer will have a y and an x inside of it. But this is my x coordinate, so this is going to go in my x1 value. This is my y coordinate. It's going to go over here in my y1 spot. So all I'm going to do here is I'm going to plug in the 3 numbers into the equation, and I get y minus y1, which was 2, equals my slope, which was 6, times x minus a x value. And all I did is, again, just plug in plug in the three numbers where they should go. There's my slope, there's my x-coordinate from right here, there's my y-coordinate from right there. The next thing we're going to want to do is we need to combine like terms here. So nothing's happening over here, so I need to, sorry, not combine like terms, I need to distribute because I got to get rid of these brackets here. So 6 times x is 6x, and then 6 times negative 2 is minus 12. Now I have one thing left to do, well, to get it in slope-intercept form, and that is to add this 2 to both sides. And when I add this 2 to both sides, that's gone. There's my y equals 6x, negative 12 plus 2, minus 10. And that is my answer in slope-intercept form. But of course, they don't want it in slope-intercept form. They want it in standard form, so we're not done yet. What do we got to do? We got to get that x to the other side. So what would I want to do? Subtract the 6x from both sides. Negative 6x plus y equals negative 10. That would be my final answer for that one there. And then it says, indicate the line's y-intercept, or my b value, the y-intercept, or b if you want to call it, equals negative 10. So that's where it would cross the y-axis. I'll walk through another one. Let's look at number 5. Number 5, it says m equals 1 with 5, negative 5. And again, I'm going to use my point slope formula. There it is, one more time. And the first thing I'd want to do is plug in the 3 values that I can into where they go in the equation. I'll take a crack at it. I'm going to let you guys try number 7 here, but if you're working ahead or something, that's fine. So next step, plug in all 3 values. Y minus my y-coordinate, that's over here, which is a negative 5. So again, we got a double negative situation brewing here. We're subtracting a negative 5 equals my slope, which is 1, times x minus my x-coordinate, which is 5. And of course, distributing by multiplying by 1 doesn't change anything at all. There's really nothing to distribute this time because I'm multiplying by 1. But I would want to clean up this double negatives because it's always subtract. What am I subtracting? A negative 5. So I would want to rewrite that as probably y plus 5. And again, nothing really to distribute here. Multiplying by 1 doesn't change anything. So this is where I would be at now when I clear out the brackets, because that's always going to what I want to do next, clear those brackets out. And now want to get y by itself, so I would subtract 5 from both sides. Y equals x, negative 5 minus 5 is 10. Y equals x minus 10. And then to get it in standard form, it's in slope-intercept form right now, but I want it in standard form, so I need to move that x to the other side here. I should subtract that from both sides. And that would leave me with negative x plus y equals negative 10. For that one here. Why don't you guys try number 7 here? This time I'll see what you can do. So same process. There's a number of steps here, and again, it's new to you, so I understand. I get you, but first thing you want to do is just make sure you get your formula that you're going to need here. Next thing you're going to want to do is plug in those three values where they go in the equation. Clear the brackets out. And then get y by itself by adding or subtracting whatever value you have over there. That'll get your answer in slope-intercept form. And then merely get that x pushed to the other side, and you'll have converted it to standard form. Okay, let's see how it worked here. So plugging it in, y minus my y coordinate, which is -6. My slope is 2 times x minus a -3. I'm just going to get rid of both of those double negatives right now. Y plus 6 equals 2 times x plus 3. That's just me rewriting without double negatives all over the place. Now I want to distribute. Whenever we have brackets, we've learned throughout the year, you can't really solve anything with brackets in there. You've got to clear your brackets out to solve stuff. So that should be our priority. We can't solve anything with these brackets here. So y plus 6 equals 2x plus 6 when I clear the brackets. Then I want to get y by itself, of course, so I'm going to subtract this 6 from both sides. Y equals 2x plus 0. If I'm referencing it in slope-intercept form, I could just call it this, but this 0 is going to matter here. Because I want it in standard form, I can't have it equal just blank air. There's got to be a value over there. 0 is a real number. But I need to subtract that 2x from both sides, which means my final answer should be -2x plus y equals 0. And again, this one was a little weird with the 0 here, but we don't, at this point, if it was in slope-intercept form, I don't really need the 0. But if I'm writing it in standard form, I can't just write -2x plus y equals blank air. That's not going to work. It actually does equal 0. So the 0, in this case, does matter. Because I got to have something on both sides of the equal sign. Otherwise, what does it equal? You have no idea. Okay? All right, let's look at number 11. So 11 here gives us a graph this time. And what we need to do, again, we're going to use point slope form. They want the answer in standard form one more time. But I need to figure out the slope of the line first. What's the slope of this line? I can approach it a couple ways. I can certainly use y2 minus y1 over x2 minus x1 to figure out what my slope is, if I want. Or I can just visually see for every one spot to the right, I go up 2, which means my slope is 2. And again, you can plug in your 2 points on the back side here. That's exactly what we're going to have to do. We're going to have to manually find the slope ourselves and then use either one of the points and run it through point slope form to finish it. But just for time purposes here, I'll tell you the slope is 2. You can either visually see it, one spot to the right, up 2, slope is 2 over 1, or you can use your y2, take your 2 coordinates that you know and calculate the slope. Hopefully you get 2. So now I know what the slope is, and then to use point slope form, you'll have to trust me on this here, but I can use either one of these coordinates and I'll get the exact same answer. Okay? If I had more time, I'd work it with both of them and show you, prove that to you. But I guarantee you 100 gazillion % that either one of these coordinates will get me the same answer. It doesn't matter. But I need a coordinate to use point slope form. I need to know the slope, I need a coordinate. So I'll let you guys pick. Do you want me to do it with 0.01 or do you want me to do it with point -1, -1? This one? Yeah. All right. So that's, again, I'm going to run the point slope formula. Bring it back here. But I have to have a coordinate too. I need to know the slope and I need one coordinate. So now I have a coordinate. And again, I can pick either one. I assure you it does not matter. So now it's the same deal. Back to the formula we go. I have all the pieces that I need. It's just a matter of the same thing we've been doing here before. Plug in the values, y minus my y value, -1, equals my slope times x minus my x value. And very similar to the last one, I'd probably just rewrite without all these double negatives all over the place here. Distribute 2x plus 2. Subtract the 1 from both sides. Y equals 2x plus 1. And then in standard form, subtract that 2x from both sides. -2x plus y equals 1 is my final answer there for this one here. So same deal. The only difference this time is you need to get the slope yourself. You can either visually do it if it's graphed out to you, or you can use this, the same thing we did in 6.4, and I looked at your quizzes. You both seem pretty adept at finding the slopes. I think you got them both correct on that. So you know how to do it. But you need, obviously we need the slope here to do the point slope form. Don't have the slope, you're in trouble. So again, all right, let's look at the back side here. So now we're going to be writing our answer in slope-intercept form. This time the slope is not provided to us, but that shouldn't be an issue because 15, I got my 2 points, 4, -3, and 2, 3. Okay, all it gives me is just 2 points. But that's all I need. So the first thing I'd want to do is find the slope. This time I don't have a visual, so there's only one way I can do it, and that is this way. I'm going to have to do it this way. There's no other choice. But I need 2 coordinates to find the slope. I have 2 coordinates. So I'll let you guys tell me what you think the slope is here. When one of you thinks you got it, you can shout it out to me. Or -3. Right. Do you get that too? Yep. Right. So again, plug it all out. That's my m value. My slope is -3. I need that value. So now I got everything I need. And once again, here we go. And I can choose either one of these 2 coordinates. Once again, I assure you, I'll get the same answer either one. So preference? 2, 3. Great, let's do it. So plug it in. Y minus, my y value is 3, equals my slope, which is -3, times x minus my x value, which is 2. I just plugged in the 3, the x, the y, and the m. You guys can bring up slope-intercept form. So when you're done, you don't have to convert it to standard form. So see if you can tell me what the equation is here of this line.
is negative 3x plus 9.
Nope. Right, no, you're right, I was looking at 14, sorry, Nick, you are correct. It is y equals negative 3x plus 9. So y minus 3, negative 3x, negative 3 times negative 2 is a positive 6. Add the 3 to both sides. Y equals negative 3x plus 9.
I've got times 3 and 6, or 3 and 2.
Right, yeah, double negative, positive outcome here. Last one, and then we gotta pull the plug here, so you feel somewhat okay about this here? Okay. Let's look at 21, the graphing one here, and then we will move on here as best we can. So y minus 1 equals negative 3x plus 2. And what they want you to do is write the equation in slope-intercept form, and they want you to make a graph. So I don't have any points right now, but similar to what we talked about slope-intercept form, if I can figure out the y-intercept, and I can figure out the slope, those two things alone should give me all the information I need to graph something out. So I just want to clean this up a little bit here. I'd probably want to clear the brackets out first. So negative 3x minus 6. And then I'd want to add 1 to both sides. So y equals negative 3x minus 5. And I know my two things. What's my slope?
That's 5, or negative 5.
That's the y-intercept.
Oh, and then negative 3.
There's my slope. So for every one spot I go to the right, I go down 3. Where's my y-intercept? Negative 5, or if as a coordinate, that would be coordinate 0, negative 5. So now it's just a matter, and it's going to go pretty far down. I'm going to make it like this here. The y's especially are going to go pretty far down, so it's going to be about like that. Won't need to go too far. That should be good enough here for my graph. But the one point that I know for sure is this one right here. That is for certain there. I know that point. And then knowing my slope of negative 3, what that tells me again, rise over run, negative 3 over 1. For every one spot I go to the right, I go down 3. So I go one spot to the right. There I am at x is 1, down 3. That's my next point right there. And for all practical purposes now, that's about all I'm going to get here out of this. My line would look generally something like that if I graphed it out there. So with these here, I mean, 2 coordinates is what you're going to get, but you're going to have to get your y-intercept, and again, just kind of slope it down here from that point on. So, okay?
Yep.
Okay. Good enough?
Oh, yeah.
Okay. All right. Well, 20.